In this video, I want to focus on the work that should happen before any migration starts. A lot of teams jump directly into framework upgrades, new project templates, or architecture redesign. But if the old codebase is still tightly coupled, full of hidden configuration, inconsistent logging, and dangerous database access patterns, the migration becomes much harder than it needs to be. So this is a triage video. If I inherit an old .NET codebase and I know migration is coming, I do not begin with excitement about the target platform. I begin by asking what will make every later step safer. That usually means 5 things. Reduce coupling, make dependencies explicit with dependency injection, clean up configuration, improve runtime visibility, and understand the query story before the migration locks the worst paths in. My main thesis is that migration amplifies whatever it's already true about the system. If the codebase already has hidden dependencies, configuration drift, runtime blind spots, and unstable query behavior, migration will not magically fix those things. It will usually expose them in more painful ways. That is why I prefer pre-migration triage. I want to remove the highest friction problems before I start moving frameworks, runtime versions, or hosting models. The wrong question is, how fast can we move this into the new stack? The better question is, what do we need to fix so the move becomes safe, more measurable, and more reversible? In the first hour, with an old .NET codebase, I am not looking for elegance. I am looking for danger signals. I want to know whether business logic is trapped inside controllers, forms, page handlers, or giant service classes. I want to see whether the code relies on static helpers, service locators, or singletons that hide real dependencies. I want to know whether configuration values are spread across web config, app settings tables, environment variables, and random utility classes. I want to know whether logging gives enough context to explain production failures, and I want to know whether the data access story is honest, because a lot of code bases say they have the repositories while the expansive query behavior is still hidden and operationally dangerous. This is first pass gives me the migration pain map. If I compress the pre-migration work into a usable order, I start by lowering change risk, not by touching the target runtime. First, reduce coupling so change becomes local again. Second, make dependencies visible and replaceable. Third, make configuration explicit and predictable. Fourth, improve logging correlation so the team can actually diagnose failures. Fifth, identify the worst query patterns before a migration carries them forward. And only after that do I start framework or runtime movement. Okay? This order matters because each step lowers uncertainty for the next one. The first thing I would usually fix coupling. When old systems become painful, it is often because small change crosses too many boundaries. A controller calls a helper, that helper reads config, the config chooses a repository triggers email, yada yada yada, and now one feature touches 5 concerns. That kind of coupling makes migration expensive because every technical move becomes a behavior move too. So I separate orchestration from business rules, and I create adapters around external systems like email, files, storage, payment, or legacy APIs. I am not trying to redesign the universe. I am trying to make changes local again. If replacing one concern requires many unrelated files to know about it, the coupling problem becomes before migration. The second thing I would fix is dependency injection, but in pragmatic way. I do not believe in abstracting every class to satisfy a purity rule. What I care about is making critical dependencies explicit in the places that matter most. If I important business flows are constructing repositories, gateways, clocks, HTTP clients, or file readers directly inside methods, the code becomes harder to move and harder to verify. So I replace surprise dependencies with constructor injected ones, and I introduce interfaces where they create real seams, external services, infrastructure adapters, and volatile integrations. Dependency injection is not the migration. It's what makes migration less fragile. Configuration cleanup is one of the highest return tasks before migration. Older .NET systems often evolve through multiple hosting areas. So configuration ends up split across files, transforms, machine level settings, database tables, and helper classes. That means behavior changes by environment in ways that nobody fully trusts. Before I migrate, I want to configuration inventory, what settings exist, where they come from, which are secrets, which are environmental specific, and which are that. Then I group meaningful settings into typed options, validate critical settings at startup, and remove hidden defaults to make production behavior different from the development behavior. Runtime upgrades often surface config problems first, so predictable configuration makes later migration feel much less random. The fourth thing I would fix is logging and runtime visibility. A surprising number of old code bases are effectively blind. They may write to files or event logs, but they do not provide enough context to explain what failed, where, for which request, and under which dependency state. That is dangerous migration because new failures will appear, and without visibility, the team will guess instead of diagnose. So I want structured logs, consistent severity levels, and enough request or job context to correlate events across the path. I care especially about boundaries, incoming requests, background jobs, external integrations, and database failures. Good logging is not decoration, it's operational leverage. The fifth pre-migration fix is query and data access triage. This is where many teams becomes ideological too early. They argue about the ORMs, repositories, or architecture patterns, and the real issue is the query behavior is already expensive. Before migration, I want to identify the dangerous paths. N+1 queries, unbounded lists, giant includes, reports joins on every request, and row by row background jobs that should batch. Then I separate transaction-oriented flows from hot reads and reporting flows. I do not assume one data access style must fit everything. The correct choice depends on query shape, write behavior, and operational cost. The goal is modernize with evidence instead of carrying invisible performance debt into the new platform. It is just as important to say what I would postpone. I would postpone board architecture rewrites, microservice decisions, wide scheme redesigns, style-only refactors, and most front-end rewrites unless the UI is the main blocker. Not because those topics never matter, but because they are often high noise and low leverage at the start. If the codebase is still tightly coupled, poorly observable, and operational unpredictable, those larger redesigns just stack risk on top of confusion. My rule is simple: postpone work that looks modern but does not yet make the change safer. So if I inherit an old .NET codebase and migration is on the horizon, I do not start with the migration. I start with the triage. I reduce coupling, make dependencies visible, clean up configuration, improve runtime visibility, and understand the query story. That work may not look glamorous on a slide, but it is usually what separates calm migration from chaotic migrations. The goal is not to make the system look new. The goal is make it movable. If this lands well, the next deeper videos can focus on logging and observability. Before migration, query triage is in legacy apps, or how to crave a safer first slice in a .NET larger monolith. By the way, if you like this video, please subscribe and like them. See you on the next videos. Thank you.